exponentials, there are a few things that I want to talk about with just exponential terms in general. Okay, so when we talk about an exponential function, it is the x being the exponent that makes this exponential. Okay, let's make a note of that. Okay, so x being exponent is why this is exponential. Right? Because we can have functions that have other exponents, right? We've already seen one, like the quadratic. It had an exponent of 2, that made it quadratic. So it's the x part, or the variable being an exponent, that makes this exponential. Now, regardless of what the exponent is, whatever it is that we take and raise to that specific exponent, that's considered the base. So this variable of b is our base. So it's always some base raised to an exponent. All right. I actually want to skip most of this. I want to talk, I lied. Let's talk about this. Okay, so when we talk about exponential functions, there is this value of k, and in all our other functions, we've talked about that as being our starting y coordinate. It's different for an exponential function, where this value of k is called the asymptote, okay, or the tail. We're going to graph that on our line as on our graph as a horizontal line. Okay, and that's going to be one of the first things that we plot when we graph our exponential functions. Okay, we'll talk about why that shows up. It does require a pretty good understanding of exponents. Okay, but yeah, that value of k is going to be an asymptote, or the tail of our graph. Another thing that we're going to do is we're going to start talking about y-intercepts. Okay, that's going to get plotted for every exponential function that we graph here. So a y-intercept, if we don't know, that's where the graph crosses the y-axis. And if we remember, on the y-axis, there's a way that we can write the equation of that y-axis. Okay, because on the y-axis, every single point has an x-coordinate of 0. So y-intercept has an x-coordinate of 0. That's important for us to know, not only for an exponential function, but for every function that we might graph. Now, I want us to look at something here. If we were to take this exponential function and we plug in 0 for the exponent, or for the x, let's see what we get for that. So b to the power of 0 plus k. So in your calculator, I want everybody to pick some random number. Okay, I don't care what number it is. Okay, it can be 9, it can be a decimal, okay, it can be a million, I don't care what it is. So let's say I'm going to pick 3. Okay, I'm then going to take it to an exponent. Your exponent button is right, it's this button that has the upwards arrow. Okay, it's called the caret. If you're using these yellow calculators, it's diagonal from the number 7. You're going to press that. Then make your exponent 0, and everybody should get the same number no matter what the base is. What is everybody's calculator saying that you get? 1! Everything to the power of 0 is 1. Even if I take a crazy number and I raise it to the power of 0, okay, it is still just 1. Okay, so b to the power of 0 is 1. And so our y-intercept is always one value above where that horizontal asymptote is. Okay, and that'll be a kind of a product with how we graph these exponential functions anyway. Okay, but that's a good introduction to finding y-intercepts and also how to use the calculator here. All right, so now, another thing I want us to do when working with exponential functions. I want us to be able to decide when we look at the equation, is it increasing or decreasing? Okay, so when I'm talking about increasing or decreasing, it's very similar to like a negative and positive slope line. And remember, one way that I talked about how we can remember that is imagine that you're walking across the graph starting on the left side. And if you are on the left side and you start walking to the right, if you're going down, that means we are decreasing. So this graph here is decreasing. And when I look at the equation, I'll know that it's decreasing because the base will have a value that is between 0 and 1. Okay, so essentially a decimal or essentially a fraction. Not all decimals, not all fractions are between 0 and 1. So we need a specific decimal or fraction between 0 and 1. Yeah, go ahead. Okay, the next graph. Okay, if I look at this and I start on the left side and I start walking to the right, this time I'm going to be walking up the hill. So that means this graph is increasing. When our graph is increasing, that tells us something about the base, or the base tells us that it's increasing because the base is greater than 1. Okay, so any number bigger than 1 will have a base that is increasing. So now, I've got two examples here, okay, with their equations. And I want us to pick up on two things here. Okay, again, seeing the base in the on the graph is a little bit trickier. That's not really something that we'll see. We're going to more get points and plot those using the base. But here are two things that I can see from the equation right away. That is this horizontal asymptote, or the tail. And so when we graph exponential functions, we're going to plot that asymptote right away. We're going to plot the tail. Okay, so whatever that number is that we add or subtract, we're going to graph that on our line as a dashed line, and it is horizontal. The reason that we kind of refer to it as the tail is because that's what our graph approaches as we keep going further left. Now, one really important thing about this asymptote, the graph gets really close to that line, but it never goes below it. So even if I were to continue this graph all the way to the left, like to negative infinity, we're still never below that horizontal line. Okay, so when we graph that asymptote, the graph will always be above it. Okay, you'll never touch it, you'll never get below it, you'll get really, really close to it. Okay, then we talk about the y-intercept. Well, the y-intercept, when x is 0, we said that that was 1 more than the horizontal asymptote. Look at that right there. 1 more than negative 7, it's at negative 6. Okay, and that's our y-intercept. Okay, for the other example here, negative 10. This is the asymptote, or that tail. We're going to fill that in as a horizontal line at negative 10. We'll notice that the graph gets really close to that asymptote and never touches it. It never crosses it. Just gets really, really close to it. Then, same thing as before, the y-intercept. That's 1 more than negative 10. So that's at negative 9. And that's going to show up with all the graphs we come up with today. All right, after you've written this all down, go ahead and flip the page over. Here we go. We're going to take a completely different approach to how we graph these, and that's why we have calculators today. But we're first going to identify two things. I want to be able to look at this equation and know if it is increasing or decreasing. I can do that by looking at the base. The base of 2 is bigger than 1, telling me that this graph will increase. So we should see that it is going up as we go to the right. The horizontal asymptote. That is a horizontal line coming from this value that we see after the exponential term. And its equation is y equals 3. Well, we're going to go ahead and fill that into our graph right away. We're going to put a dashed line at 3 all the way across. Our graph will all be above that. We will never have an exponential function below our horizontal asymptote. Okay. How we're going to graph exponential functions. We are going to come up with 5 points that we're going to get the coordinates of, and we're going to pick. When we are picking points, you'll always pick the exact same x values. So we're going to use the x values of -2, -1, 0, 1, and 2. We are going to do that for every single exponential function. So you don't need to think about what x's should I use. It'll always be the numbers from -2 to +2. We're then going to take each of these numbers and plug them into the equation of 2 to the power of x plus 3. And we're going to do that for every single one. And this is why we have calculators. Now, one thing I'll just warn us about. Negative exponents are weird. Okay, we won't talk about the rules with negative exponents quite yet. We will get to that later in our semester. Okay, so for now, when we use negative exponents, just know that it may not be what you expect it to work out. Okay? This is where you're all going to pick up calculators, and you're going to follow along and press the buttons just like I'm doing. Now, I'm going to repeat these directions 5 different times. So if you don't get them all the first time, that's okay. Listen carefully the second time. If you don't get it the second time, that's okay. Listen carefully the third time. But it is really important that we try to press the buttons just like what I'm doing. That way we know how to do this ourselves. Okay? I'm going to have us take the base and we're going to put it in parentheses. So we'll first open a parenthesis, which is right above the number 8. Then we'll type our base, which is 2. And then I'm going to close the parenthesis. Then your exponent button is this upwards arrow. We've already kind of talked about it. Diagonal from 7. It is called the caret button. So I'm going to press that caret button. It has now moved our cursor into the exponent. We want the exponent to be -2. Now, there's a difference between making a number negative and subtracting a number. We want to make this number negative, so I'm going to use the negative button with the exponent of 2. We then need to get out of the exponent, so I'm going to hit the right arrow key. So now I'm out of the exponent, and now I just need to do +3. And what this calculator gives me is a number that's a fraction. That's not all that helpful. Okay? It's much easier for us to graph a number when it's in its decimal form. So in these yellow calculators, you can then press this button that has arrows pointing in opposite directions, and it'll get you to 3.25. Okay? We'll talk about all that. It's just in between two numbers. It's not that any different than graphing a regular number. Okay, but again, a lot of buttons here. If we didn't catch everything the first time, that's okay. Listen carefully again. Okay, here we go. I'm going to do this all again. Open parenthesis. Base of 2. Close the parenthesis. Exponent button. Raising it to the power of -1. Make sure you're doing the negative, not the subtraction button. Then hit the right arrow key. Then +3. Press enter. Once again, it gives it to me as a decimal, or excuse me, a fraction. If you hit this button right above enter, that the arrows are pointing in opposite directions, it'll convert it to a decimal for us, so 3.5. Okay, again, if we didn't catch it the second time, I'm going to do it all over again. Continue to try to listen and see what parts you can do, but it is so important that we are trying this ourselves. If you are not pressing buttons right now, you are making this class a lot harder. So here we go. Open parenthesis. 2, which is our base. Close parenthesis. exponent button. This time our exponent is 0. Hit the right arrow key to get out of the exponent. Then +3. Then press enter. This time it is 4. We don't need to convert it to a decimal or a fraction. So that part is done. Again, 2 more times, going really slow, explaining every button that I press. Next one, we have open parenthesis, 2. Exponent button to the power of 1. Right arrow key, +3. Press enter, and I get 5 this time. Okay, then, do it again, parenthesis, 2. Close parenthesis. Exponent button. Exponent of 2 this time. Oops, I did not press my exponent button. Right arrow key to get out of the exponent. Add 3, and we get 7. So what we've just came up with is we've come up with 5 different points that we can then plot on our graph and connect them to come up with our graph. And that way we don't have to think about all these rules like what we've done with our other functions. Okay? So we were asking, how do we graph a decimal? We just estimate where it's going to be. Okay, 3.25, it's in between the numbers 3 and 4. It's a little bit closer to 3. So I'm going to go left 2, and then up 3, and then an extra 0.25, so just barely above my horizontal asymptote. Then I have -1 and 3.5, so a little bit further above the 3.25. Then I have 0, 4. And then 1, 5. And then 2, 7. And when we connect these, we'll show the tail, getting really close to the horizontal asymptote, and we're showing that this is increasing as it goes to the right. Okay. We're going to go through all this one more time together, okay, before class is over. Again, I'm going to explain every button with the calculator. If we had trouble with it the first time, we need to pay attention and follow along the second time around, okay? So here we go. The base, this time it is 1/3. That 1/3 is between 0 and 1, telling me that this graph decreases. So it's going to be an opposite direction than the graph we just came up with. There is a horizontal asymptote at y equals -1. We will start by just graphing that horizontal asymptote at y equals -1. And now for us to get our points, we'll create a table, and we always use the exact same x values. Those x values being -2, -1, 0, 1, and 2. This time, we're plugging in these x values into the equation of 1/3 to the power of x minus 1. For us to type in a fraction, we will do that as a division problem. So again, really important that we follow along and press the buttons, just like what I'm going to do right now. For the most part, it's the exact same, just dealing with the fraction here. So I'm going to start with an open parenthesis. To do the 1/3, I'm going to take 1 and divide it by 3. Okay, all fractions are division problems. So 1 divided by 3 representing the 1/3. Then I'm going to do the exponent button, raising it to the power of -2. Make sure you use the negative, not the subtraction button. Then hit the right arrow key. And this time we are going to subtract 1. So subtraction button, -1, and we get 8. Again, negative exponents are weird. Okay, I'll explain the whole thing again. Open parenthesis. 1 divided by 3, representing 1/3. Exponent button, raising it to the power of -1. Right arrow key to get out of this. Then subtraction button. So we're subtracting 1, and we get 2. As we keep doing this over and over, we get a lot quicker with it. Okay, again, I'm going slow for those of us that are still having trouble with the buttons. Okay, I'll go slow one more time, and I'll do the last two a little bit quicker. Open parenthesis. 1 divided by 3, representing 1/3. Exponent button, raising it to the power of 0. Right arrow key, getting out of the exponent. -1. Press enter, and we get 0. Okay, one more time. Open parenthesis. 1 divided by 3. Exponent button of +1. Right arrow to get out of the exponent. -1. This time it gives it to me as a fraction. Remember, you need to press the button going in opposite directions to get it as a decimal where it's -0.66 repeating. And then one more time, this time with 2, so open parenthesis, 1 divided by 3. Exponent button raised to the power of 2. Right arrow key to get out of that. -1. Button going in opposite directions where it's -0.88 repeating. Now we have 5 points that we can plot and get a good shape of our graph. So -2, 8, -1, 2, 0, 0, 1 and -0.66 repeating, and then 2 and -0.88 repeating. There we go. All right.